Good afternoon. How are y'all doing today? Hope the traffic wasn't too bad. Anyways, my name is Marta Gonzalez. I'll be providing an introduction. Jason, he will be analyzing the illustration. And Ethan right here is going to be providing a critique. And our topic is supercapacitors, which we learned like 3 hours ago. Not even, okay. So supercapacitors is an energy storage device that relies on an electrical double layer to store charges. It's kind of similar to what happens if you rub a balloon against your sweater and it creates a charge differential. It somewhat works on that property, but some of the applications of supercapacitors include its use in elevators, and you probably won't see this in Southern California, but some buses have supercapacitors on their surface, so every time it reaches a bus stop, it'll charge and go on and charge and so forth. And in comparison to batteries, supercapacitors have a very high power density, which means you could charge and discharge very quickly. One disadvantage, or not disadvantage, but one difference from batteries is that batteries have a larger energy density, which means it could save more power in comparison to supercapacitors. Now, supercapacitors sound difficult, but they're actually extremely difficult. Fortunately, we have a little analogy right here that Jason will hopefully make a lot more simple to understand.
Thank you, Martin. So, as they say, a picture is worth 1,000 words, and this one is no other. So, as you can see, this cartoon is split into 3 parts, 3 panels, top to bottom, and from our analysis, we have concluded that each panel represents one particular device that is used to store energy: battery, capacitor, and supercapacitor. So, the top panel, which you can see has a bus, is representative of the battery. I'll start by explaining what the picture actually means. So you can see that there's one bus on the left side of the panel, loading up a whole bunch of people, and then ferrying them over to the destination. However, it takes them a full hour to do so. This is similar to the battery, and that the battery is able to store a great deal of electricity, a great deal of electrons inside of the battery. However, it takes a long time to charge, load the people onto the bus, and also a long time to discharge, get the people off the bus. Now, the middle panel is an analogy for the regular capacitor. As you can see here on the left side, there's a smaller group of people loading onto a single van. However, that van is able to get those people to the destination in half the time, 30 minutes. Similarly, capacitors are able to charge and discharge much faster than batteries. However, their maximum capacity for storing energy, their energy density, in other words, is lower than batteries. And then the bottom panel represents a supercapacitor. So as you can see, it kind of looks like they're on a highway with multiple cars, and those cars are able to get to the destination in, half the time, only 15 minutes. And it also says destination first place over here. So how does this relate to supercapacitors? Well, supercapacitors are able to store or just charge and discharge even quicker than capacitors. Now, this is where nanoscience comes into play. The electrodes inside of supercapacitors are blessed with a much higher surface area to volume ratio due to using nano-sized materials. As an object gets smaller, the ratio of its surface area to its total volume increases. And at the nanoscale, well, as represented by this picture, there are a whole bunch of cars compared to only one bus and one van in the other 2 diagrams, pictures. But here, there is a much larger surface area or spaces in order to store the electrons or people. So thus, the supercapacitor is able to charge and take in far more electrons or far more charge than either the battery or the capacitor are able to do.
So as Jason said, the batteries take a longer time to charge and discharge their electrons, and that's because to store energy, the batteries have to go through a chemical reaction, unlike the capacitors, which just require a physical reaction. And to show this difference, I think the artist or illustrator could have added maybe a pay station where they had to get onto the bus, just to show the difference between the longer time that the electrons have to travel to take. And on the bottom panel, you can see people standing outside the cars, but you don't really know what they're doing, unlike the top two panels where it shows arrows of indicating them going in and out of the cars. So I think they could have added arrows just to make it more clear. But overall, this analogy was pretty clear to understand and relatable. So yeah, thank you. Do you have any questions?
The supercapacitor, the electrodes that are inside the supercapacitor are usually made of materials that have, well, nanomaterials. And nanomaterials are, for example, one we used earlier today was called activated carbon. It was carbon that had been treated so it had many numerous fissures or fractures inside of it, which would increase the amount of total surface area that is exposed to whatever the activated carbon is exposed to. So these nanomaterials will just have much more surface area on the outside of their molecules or the outside of their particles, which enables them to interact in a much greater scale than normal materials would. So that's what makes supercapacitors much more have much more power density than capacitors.
Just to add on from the previous question, a general thing in nanoscience is increased surface area. Almost every question is surface area, including here. So with nanomaterials, you have a much larger surface area, and that gives a lot more opportunities for the charges to accumulate within the supercapacitor, and that's what makes the difference between capacitor and supercapacitor. One is made up of nanomaterials that enhance the surface area and allows the charges to accumulate much more efficiently and better than a capacitor.
What can you guys tell me about the speed of a supercapacitor versus a capacitor? Because I think there's some stuff maybe in the drawing or what you presented that was not entirely right. So which is faster, a capacitor or a supercapacitor? You guys try first.
As a matter of fact, I think
You've only got two choices, so you're 50% on to be right no matter what you say.
As a matter of fact, I believe the capacitor is technically faster at discharging and charging.
Yep.
Although
For sure faster, way faster. Like a couple orders of magnitude faster. So what's good about the supercapacitor?
the supercapacitor is able to charge up a significantly larger amount of energy.
Store more. Little slower, still fast, stores more. Okay, so now can you tell me how you might modify the picture to capture those ideas?
Perhaps I could modify that 30-minute timer on the van picture to be 5 minutes, maybe 1 minute. So, or, well, just in order to show that the van makes it to the destination much faster than the bottom one, I guess.
And that would be pretty easy because what do you see at the bottom that might actually justify that?
It could be possible traffic. This whole.
Sure,